Hello, this is a walkthrough for the Edexcel Paper 3 Foundation Tier from June 2023. Your time allocated is 1 hour and 30 minutes and you're allowed to use a calculator. In order to benefit most from this walkthrough, I would recommend completing the paper in advance, or alternatively, as you get to each question, pause the recording and have a go before playing again. Question 1. Write the number 3,107 in figures. So 3,100, nothing in the tens column, and 7 in the units. Write 3/10 as a percentage. So 3/10, if we change 3/10 to a decimal, it's going to be 0.3. We can do this in the calculator quite easily. Just pop this in, this little SD button will change that to a decimal. If we then multiply it by 100, that will change our answer into a percentage. So 0.3 times 100 gives us 30%. Simplify m plus m plus m plus m would give us 4m. Question 4, change 4,000 grams into kilograms. So we've got 1 kilogram. We're going to go from kilograms to grams. We would multiply by 1,000. Grams to kilograms, we're going to do the opposite, which is divide by 1,000. 4,000 divided by 1,000 is going to give us 4 kilograms. Question 5. Write these numbers in order of size. Start with the smallest number. If you think about your number line, the smallest is going to be the most negative, so -5, then -2, 3, 7, and then 9. Question 6. The diagram shows a shape on a centimetre grid. Part A, find the area of the shape. So what we want to think about is the surface covered by this shape. This is going to be the easiest way to work this out, is just going to be to count these squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 centimetres squared, as it's an area. Part B, find the perimeter of the shape. So this is as we go around the edge of the shape, we're going to add up the length as we travel around. So this is going to be 2 centimetres. Let's just work out what they all are first. This is going to be 4, 1 centimetre along here, 2 centimetres, 3 centimetres along here, and 6 centimetres here. So to work out the perimeter, we need to add up those lengths. Which should give us an answer of 18 centimetres. Question 7. Here is a 4-sided spinner. We have the numbers 1, 2 2s and a 3. Samina spins the spinner once. Choose the word that best describes the probability that the spinner lands on a 2. We have, out of a total of 4 numbers, we have 2 2s. So it's going to be evens. Choose the word that best describes the probability that the spinner lands on a number less than 4. So if we look here, all of the numbers are less than 4. This one is going to be certain. Ralph rolls a biased dice once. The probability he gets the number 5 is 0.4. Work out the probability that Ralph does not get the number 5. So we're using the fact here that total probability adds up to 1. Probability that he gets a number 5 is 0.4, so the probability he doesn't is going to be 1 minus 0.4, which is going to give us an answer of 0.6. Question 8. A quadrilateral has 4 right angles and 4 sides of equal length. So drawing out a little sketch, we've got 4 right angles, 4 equal sides. This is going to be a square. Part B, the diagram shows a solid shape. Write down the mathematical name of this shape. This is a cuboid. Question 9. The table shows the number of books read by 4 people in 1 month. Work out the median number of books. So the median number, if we write the numbers in order, we are looking for the centre or the middle of the list. So if we cross off from either side, we can see that the centre of this ordered list is going to be halfway between 5 and 7, which is going to give us a median of 6. The range is the biggest value, take away the smallest value. So in our table, we can see the biggest value is 9, smallest value is 1, and that gives us a range of 8. On the grid, draw a bar chart to show the information in the table. So we want to start with thinking about the scale on the left-hand side here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 squares there. The maximum frequency that I need to plot is 9, so I can go up in ones. I'm just going to label every other one because otherwise it's going to get a bit squashed there. So that's going to be 2, 3, 4, 5, 6, 7, 8, 9, and 10. I need a label on my axes, so I'm going to call this number of books. Frequency is also totally fine to label on this axis. And then we want to label the people along here and draw in the bars. So the first one is going to be 7. So we want nice equal bars with nice equal spaces between them. So I'm just going to go with a space of 1 and a bar of width 1. Then the second bar is going to be 9. So if I leave 1 space. Then the next one's going to be 1 high. And then 5. I need to put labels along the bottom. There's not a lot of space to write the full names out. So I'm going to label these with the first letters of everybody's names. Question 10. Wayne begins walking at 8:30 a.m. He walks for 1 hour and 45 minutes. He then rests for 15 minutes. He then walks for 85 minutes to a cafe. Does Wayne get to the cafe before 12 noon? You must show how you get your answer. So I'm going to think about the timeline for this one. So he's going to start walking at 8:30 a.m. Okay, so he's going to walk for 1 hour and 45 minutes. So let's break that down. 1 hour is going to take me to 9:30 a.m. and I want another 45 minutes. So that's going to take me up till 10 and then another 15 minutes. It's going to take me to 10:15. He's going to rest for 15 minutes. So that's going to take him up to 10:30 a.m. And then he's going to walk 85 minutes to a cafe. So let's have a think about splitting that up into hours and minutes. So that's going to be 1 hour. So 1 hour is 60 minutes, isn't it? We've got 25 minutes left over. So 1 hour is going to take him to 11:30 a.m. and then a further 25 minutes. That's going to be 11:55 a.m. So does Wayne get to the cafe before 12 a.m.? Yes, he does. So he has 5 minutes to spare before 12 o'clock. Question 11. Gabrielle thinks of a number. He multiplies his number by 5 and then adds 7. His answer is 72. What number did Gabrielle think of? So he thinks of a number. Let's think about what's happening going forward. So he's going to multiply his number by 5 and then he's going to add 7 and his answer is 72. So what we want to do is work backwards. So sort of think about it like a function machine. And we're going to do the opposite, going backwards. So rather than adding 7, we're going to subtract 7, which is going to give us 65. And then we are going to divide by 5. So it's calculator paper. And put these steps into your calculator. It should give you 65 divided by 5 is 13. Okay. You'd want to just check 13 times 5, add 7, just to check you get back to 72, which you do. So his original number is 13. Question 12. Some students took a guitar exam. The pie chart shows information about the grades the students got. We've got pass, fail, distinction and merit, and we've got the degrees included. I'm going to write down the modal grade. So the modal comes from the mode, which is the most common. So we can see the biggest slice here is going to be merit. 7 students got a distinction. Work out the total number of students who took the guitar exam. We've got 7 students. It's going to be 105 degrees. So it's always useful to work out what is one student. So how many degrees for one student? So if we divide this 105 into 7 parts, it's going to give us 15 degrees. So we know one student, 15 degrees. You may have worked out how many students failed, how many students passed, and added them up. You can also, as well, just think about, so the total number of degrees in the pie chart is going to be 360. If we divide that by 15, we get 24 students in total. Question 13. Rowena drove from her home to a beach. Here is a travel graph for her journey. On the left-hand axis here, we've got the distance from home in miles, and along the bottom, the time. So Rowena stopped at a cafe on her way to the beach. Okay, so when we stop, that's why the line is horizontal. So this is going to be the point where she reaches the cafe. And then this point here where she arrives at the beach. So how many minutes did Rowena take to drive to the cafe? So if we read down from here, we've got 4 squares for 1 hour. So each one of these little squares is going to be 15 minutes. So 15 minutes and 15 minutes is going to give us 30 minutes. This will be 12, 30. Write down the distance from Rowena's home to the cafe. So if we read across here, that's going to be 10 miles. Rowena stayed at the beach for 1.5 hours. She then drove home without stopping. Rowena arrived home at 1600. On the grid, complete the travel graph. So let's see, what time does she arrive at the beach? That's going to be, if we read down from here, so she arrived at the beach at 1:30 and she stayed there for 1.5 hours. So that's going to take us to 3 o'clock. She stopped, she's not moving any further distance, so that's going to be horizontal line, and then she arrives home at 4 o'clock. So we're going to have a line joining 3 o'clock till 4 o'clock when she arrived home. Part C, work out the average speed for the journey from the beach to Rowena's home. Okay, so if we want to work out the speed, we need to think about the distance she travelled over the time taken. So let's have a think. The distance that she travelled, so she was 35 miles away from home, so that's going to be 35, and it's just divided by 1 hour. So that's quite an easy calculation there. We've got 35 miles per hour. Question 14. 120 boxes cost £6. 270 bags cost £10. A bag is cheaper than a box. How much cheaper? Give your answer in pence correct to 1 decimal place. Okay, so let's have a think about boxes first. So it's asking me to give my answer in pence. So what I'm going to do is change that £6. That's going to be multiplied by 100 to change it to pence. It's going to be 600 pence. So I've got 120 boxes. So to work out the cost of 1 box, I'm going to divide 600 by 120. And into the calculator, that's going to give an answer of 5 pence per box. Let's do the same now for bags. So we've got £10 and we've got 270 bags. So £10 is going to be, times it by 100, 1,000 pence, and 270. So we're going to do cost for 1 bag is going to be 1,000 divided by 270. And put that into the calculator. It's going to give an answer of 3.707. It says to give your answer correct to 1 decimal place, so that's going to be 3.7 for 1 decimal place. We want to work out how much cheaper, so let's work out the difference between those two. It's going to give me 1.3 to 1 decimal place. There are only red beads and green beads in a bag. The number of red beads to the number of green beads is 1 to 4. So let's draw out our boxes for the ratio. So we've got red to green, and we've got green is 4 parts of the ratio. We're given that 35 red beads are in the bag, and we need to work out the total number of beads in bags. So 1 part of this ratio is going to be 35. Let's have a look. So we've got 35 for each of these 4 parts. So there should be 35 times by 4, which is 140 green. Okay, so we want the total number of beads. 140 plus 35 is 175 beads in total. Question 16. Describe fully the single transformation that maps shape A onto shape B. Let's just have a quick look. It's worth 2 marks, this question. Okay, so shape A we are starting with, and it's mapped onto shape B. So the shape, as you can see, turned around. It's the same size, so it's not going to be an enlargement. It's rotated around, so this one is going to be a rotation. It's gone from being horizontal this side to vertical. It's gone 90 degrees, and it's going in this direction, which is anti-clockwise. The other bit of information that we need to include is the center of rotation. It's a little bit trickier. You should, on your desk in your exam, have some tracing paper. So what you would need to do is place your tracing paper over your shape. You want to draw over the shape A, and then so if you think perhaps your center is here, you want to put your pencil here and then turn 90 degrees. See if this A will end up on B. If not, then you need to adjust your center slightly. You should find that the center is at 0, 0. So just a bit of trial and error to work that one out. Question 17. The diagram shows the position of town E. We've got a north arrow here and a little cross of town T. Town R is 55 kilometres from town T on a bearing of 65 degrees. Mark the position of town R with a cross. Use a scale of 1 centimetre to 10 kilometres. So 2 marks here. There's 2 things that we need to do. Firstly, we need to draw an angle of 65 degrees, and then we need to think about how long it's going to be. Okay, so let's pop the protractor onto point T, and then we want to look at whichever scale starts from a 0 at this north arrow, and we're going to go clockwise to 65 degrees for our bearing. So we mark a little mark there, and then let's take this protractor away. We need to think about our scales, so using a scale of 1 centimetre to 10 kilometres, so 55 kilometres, if we divide that by 10, that's going to give us 5.5 centimetres. So what we want to do is draw a line 5.5 centimetres long on this bearing. And then we mark at the end of it town R. Question 18. Solve this equation. Step number 1, we are going to multiply out these brackets. So we want to multiply both of these terms inside by 4. That's going to give us 8x minus 12 is equal to 20. Then when we're solving an equation, we need to do the inverse, we see here. So we've got 8 times x minus 12 equals 20. So the first step is going to be to add 12 to both sides, which is going to give us 8x is equal to 32. Inverse of multiply by 8 is divide by 8. I'm going to get it at x is equal to 4. We can check our answer by substituting back in here. So 2 times 4 is going to give us 8. Take away 3 gives us 5. And then multiplied by 4 gives us 20. So we can be confident that the answer is correct. Question 19. Jenny invests £3,000 for 6 years at Y% simple interest per year. At the end of 6 years, Jenny has received a total of £450 in interest. Work out the value of Y. So let's think about how much interest is she going to receive per year. It's simple interest, so it's going to be the same amount every year. So let's divide that by 6. 450 divided by 6 is going to give us £75 per year. In order to work out the interest rate, we need to work out that as a percentage of the original amount. And the easiest way to do that is if we take 75 and we divide it by the original 3,000, and then we want to multiply it by 100% to change it into a percentage, and that's going to give us 2.5%. Question 20. Simplify m squared to the power 3. So when we have this situation with the brackets, what we're going to do is multiply the powers. So we're going to have m to the power 2 times 3 is going to be m to the power 6. When we multiply, so for part B, x to the power 5 times x to the power 8, we're going to add the powers. It's going to give us x to the power 13. And when we expand this bracket, we're going to multiply both terms by 4p. It's going to give me 4p to the power 3 plus 4p times 3p. So 4 times 3 is 12. P times p is p squared. You might be tempted to try and simplify this further. It doesn't. We just need to keep that as 2 terms. Question 21. Johnny wants to know how much coffee he will need for 800 people at a meeting. So each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup of coffee. Johnny assumes that 68% of the people will drink coffee. Using this assumption, work out the amount of coffee Johnny needs. Give your answer correct to the nearest gram. Okay, so let's have a think about, first of all, how many people will be drinking coffee. So we've got 68% of 800. So as a decimal multiplier, 68%, 0.68. Multiply those two, 800, 0.68. That's going to give us 544 people that will drink coffee. Each person will drink 2 cups, so 544 times 2. It's going to give us 1,088 of coffee. It's always useful to write this down, keep track of where we are, what we're working out. So we got that many cups of coffee. We know how much, how many grams of coffee is needed for each cup. So let's multiply those two. It's going to give me 11,532 0.8. And we want to round that to the nearest gram. So that's going to be 11,533 to the nearest gram. Ronnie's assumption is wrong. 72% of the people will drink coffee. How does that affect your answer to part A? So he thinks 68%. Obviously 72 is more, so he's going to need more coffee. Question 22. ACF and ADG are straight lines. BCD and EFG are parallel lines. Show that triangle ACD is isosceles. So ACD is this triangle up here. Just a reminder, isosceles triangle has got 2 equal sides and 2 equal angles. So angles in parallel lines. You may well have done this in a different order, but I'm going to start with this angle 125. So I know that these 2 angles here are angles in a straight line, so they add up to 180 degrees. So 180 degrees minus 125 is going to give me 55 degrees. Okay, so I'm going to describe this one. So the way we describe the angle is we draw it out. So if we describe that one, we're going to call it AFG is going to equal 55 degrees. And the reason angles in a straight line add to 180 degrees. Okay, so I'm working up to this triangle. So if I look at this angle here, and I look at this angle here, I can see that those 2 angles are equal. So I'm going to say ACD is equal to AFG, and they are your F angles or corresponding. That's the language we need there. So I know this angle here. I'm going to move over to this angle here. I know that angles in a straight line equal 180, so 180 take away 110 is going to give me 70 degrees. So ADC equals 70 degrees. And again, that's angles in a straight line. Okay, so I know this is 70, this is 55. I could do with working out this angle at the top here. So I'm going to do 55 plus 70 is equal to 125 degrees. And because it's a triangle, I know that they add up to 180. This angle here is going to be 55 degrees. So let's just write in our final reason. So CAD is equal to 55 degrees because angles in a triangle are between 180 degrees. Okay, so then I can see that these two angles are now equal. So ACD and CAD are equal to 55. So let's just ACD is equal to CAD. Therefore, it's an isosceles triangle. We try to be specific when you're describing your angles here. It's always good to label them, and also just don't forget to include your reasoning then to get the full marks. Question 23. It takes 14 hours for 5 identical pumps to fill a water tank. So 5 pumps, 14 hours. How many hours would it take 4 of these pumps to fill another water tank of the same size? Okay, so just be a little bit careful with these ones. If we think we've got 5 pumps pumping water in, if we're going to have 4 of these pumps, it's going to take longer. Okay, the way we would do this is to work out how long would one pump take. So obviously if one pump's working on its own, it's going to take 5 times longer, isn't it? So it's going to be 5 times 14 hours. That's going to take 70 hours for that single pump to fill the water tank. Okay, so if I then have 4 pumps working, it's going to be 4 times as fast. I've got 4 times as much water going in. So let's take that 70 hours, divide it by 4, which would give us an answer of 17.5 hours. So just be a little bit careful with these ones where we've got pumps or perhaps people doing a job. Sometimes we need to multiply and then divide rather than the opposite. Question 24. A and B are numbers such that A is equal to 2 squared, so that's going to be 2 times 2, isn't it? 3 to the power of 4, so that's 3 times 3 times 3 times 3 times 7. Okay, and B is going to be 3 times 3 times 7. Okay, and we've got to find the highest common factor of A and B. So the Venn diagram method is a good way of organising this one. Two circles. So what we want to do is think about what's common to both A and B. Okay, so we've got 3, and another 3, and a 7. And then let's fill in the rest of the Venn diagram as well. So for A, we've got left a 2, a 2, and a 3, and a 3. And for B, we've got a 7. Okay, so what we've got is essentially we've just got the overlap between them once. The highest common factor is going to be the numbers in this intersection multiplied. So the highest common factor is going to be 3 times 3 times 7, which is 63. And for part B, the lowest common multiple of A and B. So that is all the numbers multiplied. So all the numbers we can see here, it's going to be 2 times 2 times 3 times 3. And if we put those into the calculator, we should get an answer of 15,876. Put that on the line below. Question 25. Lava flows from a volcano at a constant rate of 11.9 meters cubed per second. So how many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? We've got to give our answer to the nearest day. So first of all, we've got the rate at which it's flowing. So let's work out how many seconds it's going to take. So let's take our volume of lava and divide it by 11.9. And that's going to give me an answer of 5. And that's going to be seconds. So we're looking at around about 5 million seconds. So let's scale that into days. So seconds, we're going to go next to minutes. So if we divide by 60, let's work out how many minutes that's going to be. If we do divide by 60 again, that's going to tell us how many hours. And 24 hours in a day. So let's divide by 24, which is going to give 65.36 days. We want it correct to the nearest day. So 3 would round down, wouldn't it? So it's going to be 65 days. Question 26. Here is the graph of y equals x squared minus 2x minus 2. And we need to write down the coordinates of the turning point on this graph. So the turning point here is going to be this minimum point. So let's read off the coordinates here. So the x coordinate is going to be 1 and the y coordinate minus -3. Part B, we write down an estimate for one of the roots of x squared minus 2x minus 2 equals 0. Okay, so this is the point where it's going to cross the x-axis. Well, there's 2 points actually where it's equal to 0. We could have this positive solution or this negative solution. So if we read off this positive solution where it's equal to 0 is going to be 2.7. You could also have a solution of negative 0.7 if you went for this other one here. Question 27. A solid cuboid is made of metal. The metal has a density of 9 grams per centimetre cubed. The volume of the cuboid is 72 centimetres cubed. And we need to work out the mass of the cuboid. So we need to know here our formula linking density, mass and volume. So we've got mass on the top, density and volume. So it's worth checking they're in the same units, that we don't need to do a conversion. So they are, they've got centimetres cubed, got grams, and we've got grams in the answer. So we want to work out the mass. So if we cover that one up, we can see that it's going to be density times volume. And that's going to be 72.6 or rather 9 first, is it? It doesn't really matter which way round. We're going to multiply them, and that's going to give us an answer of 648 grams. Question 28. Write 9 times 10 to the power 4. So it's a ratio. So to 4.5 times 10 to the power 6 in the form 1 to n, where n is an integer. So it might be a bit easier if we take these out of standard form. So this is going to be 9. So we shifted it 4 places. We need 4 zeros to fill those spaces. So it's going to be 90,000. This one here. So 4.5 times 10 to the power 6. So it's going to be 450,000. And we want to put it in the form 1 to n. So in this case, how do we get from 90,000 to 1? We're just going to divide by 90,000. So 450,000 divided by 90,000 is going to give us 50. So ratio is going to be 1 to 50. Part B. Write the following numbers in order of size. Start with the smallest number. So we've got different. So none of these numbers particularly in standard form. We can use our calculator to help us with this one. So if we go and we put, for example, the first number in, so 5.625. And this button here at the bottom, so this little times 10, and we put the power 4 in. And that is going to convert it to an ordinary number for us. So that one's going to be 56,250. So this is already as an ordinary number. We can also do the same with the negative powers. So if we go back to the calculator, we've got 5, 6, 50 to the power negative 3. If we change that to decimals, it's going to be 56.25. So you also, if you put this one in to your calculator, it's going to change it to 562.5. Okay, so we want to start with the smallest number. It's a bit confusing. I put a comma there. It looks like a decimal place. So let's have a look which one is going to be the smallest. So that's going to be, this one's the smallest, isn't it? 56.25. Then we're going to go to 562.5 over to this one, and then finally this one's our biggest one. Okay, and then we want to rewrite them in the original form. So what we're going to start with here is 6,000. Let's write this whole original format. That's our first number. Second one, we'll put 0. 3, and finally this one. And that takes us to the end of the paper. Thank you for listening, and best of luck with your exams.